All right, here's question 2f. This is the last part of question 2. It says a car is traveling at a constant speed until the car's brakes are applied. The car's speed changes at a rate of negative 0.8 t meters per second squared after the brakes are applied, where t is the time since the brakes were applied. Okay, now we can maybe draw a little bit of a map of this here. So we've got a car traveling along. I've got a, here it is, it's I'll put here t equals 0. Here's the start where we are. And at the start, the acceleration is negative 0.08 t. And what else we got here? 3 seconds after the brakes are applied. So let's call this point here 3 seconds. So t equals 3, assuming the acceleration is the same, negative 0.08 t. And we've got a v here. We've got a v is equal to 5. That's meters per second. So here we do not know what the v is. And it says, how far will the car travel with the brakes applied before it stops? So the brakes are applied from here. So really you're finding out how far from here. You just happen to know this is just a reference point. It's saying, by the way, at this time here, this is the velocity. But we're going to use this to find out the information here, to find out the equation for distance. So let's write down what we know. So we've got an equation for acceleration. Acceleration is equal to negative 0.08 t. We've got one for velocity, I suppose. What have we got? Velocity is equal to negative 0.08. This is going to be anti-differential. So it's going to be 2 on 2 plus c. So we'll tidy that up. V is equal to negative 0.04 t squared plus c. But we do know one of the parts for velocity. We know that when velocity is 5 and the time is 3, we could find c. So let's put that in there. Yes, we could find the initial velocity. So let's do that now. So we know velocity is 5, negative 0.04 times t. We know the time there is 3. That's squared. Plus, we don't know c. We're going to find c. So we've got 5 is equal to negative 0.04 times, 3 squared is 9. 9 fours are 36. So it's going to be 5 is equal to 36. So it's going to be negative 0.36 plus c. So c is equal to 5 plus 0.36. So c is equal to 5.36. And that's going to be meters per second. So velocity now, we've got an equation for velocity, is equal to negative 0.04 t squared plus 5.36. All right, so are we getting any closer to where we've got to get to? So we've got to find, it says, so here we know v now is equal to, and I can actually write that v value in there actually. Here it is. So v is equal to negative 0.04 t squared plus 5.36. So we're getting a bit closer. Now let's find the equation for s. S is really the goal here. So S, so how are we going to find S? Well, first of all, we really need an equation for t. So why don't we find out what happens when the velocity is 0? Yeah, so if the velocity was 0, for example, so 0 is equal to negative 0.04 t squared plus 5.36, and subtracted 5.36 from both sides. So that's nice. So now we've got negative 0.04 t squared is equal to negative 5.36. And I divided both sides by negative 0.04 divided by negative 0.04. T squared is equal to, and let's see where we land with that. T squared is So I'll just do it on the calculator straight into it. Let's have a look. So we've got a negative 5.36 divided by negative 0.004, or 0.04, is 134. So t squared is 134. So find the square root of both sides. We can't have negative distances, and this is going to be distance. So we're going to have, so t is going to have to equal the square root of that. Cannot be negative. So here we go, and there is our answer, 11.575. So 11.5758369. I think that's exact, by the way. I don't think there's anything else there. But let's just say that's t. So we found t when v equals 0. So having found that, we can now create an equation for s. So s is equal to, now I've got my velocity equation, which is negative 0.04 t squared plus 5.36. I'm going to integrate this, or to anti-differentiate, increase this power by 1, divide by the new power, increase this by 1 and divide by the new power, and throw in a plus c. Well, in this case, the distance at the start, this is s here, s must be 0 at the start. It hasn't moved, essentially, as far as we're concerned at least. So let's go ahead and do this now. So now we're going to put s, but this time we're going to put a t value. So I'll put let t equal 11.5758 ... Yeah? So let's put that in there. So it's going to be negative 0.04, 11.57 ... cubed on 3 plus 5.36. I'll put times 11.57 ... and that's just over 1 to the power of 1. And that equals, let's see what we've got there. So let's have a look. So we've got, so it was going to be negative 0.04 times, and we've got the thing we had before, which was 11.5758369. That was going to be cubed, and the whole thing was going to be divided by 3, plus 5.36 times, again, 11.5758. I'm having to read this off another bit of paper, sorry. So that's why it's taking me a while. Close brackets equals, I get 41.3643. All right, so equals, I'll write it in here. Here it is. 40, what do I get? 41.36. 4328. 423. I don't think it matters too much at this point, because I'm not going to do any more. I'm just going to go, that's what we've got. I'll put ... And this, of course, we're finding how far will the car travel. And these are going to be in meters, yeah? So equals 41 point, I'm going to call that just 36, I think, 36 meters. And I'll put here 2 dp. So that's how I'd go ahead and do that one. Yeah, that would be my answer. Probably a context statement would be good. I mean, you've got a fair amount of writing up here, and you want to say, therefore, the car will travel a total of 41.36 meters, and I'll leave it like that. And that would be my answer.